Hello everyone. We are talking about process selection in manufacturing for this presentation. Remember, we are not going to talk about product design and development. We are only talking about process. Process is the key word for this particular presentation, but for manufacturing industry only or making a product thereby. So process selection is nothing but product design consideration which might include the process differences between intermittent and repeated operations. What are they? The amount of product volume being produced that we are looking into it, and the degree of standardization that can be expected. The degree of, if it is 100% standardized, it becomes a very easy process for you to go around it. But if it is being customized every now and then, things get delayed and process get complicated. So process selection becomes a must needed things altogether. So we are talking about intermittent and repetitive operation. What are they? Let us understand. I am just going to marry and probably vary their positions with respect to the certain parameters that has been mentioned on this decision things. If there's a product variety, intermittent operation is great, but repeated operation probably there cannot be a product variety. It is repeatedly more or less standard. Degree of standardization in intermediate is absolutely low, but in repetitive is very high because every product will become a standard product. Organization of resources in repeated function is line flow to accommodating process, but in intermediate operation it is grouped by function. Batch 1, batch 2, batch 3. It's like your let's say we are producing face cream for a sensitive skin, face cream for a normal skin, face cream for an oily skin, and so on and so forth. Now these are intermittent operations that we are looking into it. Path of product through facilities in a variety of pattern depending upon the product needs is in intermittent fashion, but in a repeated it is goes seamlessly with the production. It is a part of the line flow process. Factor driving the production is customer orders and intermittent thing. It is customized. You remember? Did I say it's customized? It's like going to a tailor or to a fashion expert and asking him or her to design clothes for you altogether. So it's customers. We have different body types, right? All of us. But in repetitive operation, it is forecasting on the future demand. So basically, we're looking at what the market is going to predict or probably demand in future, and accordingly we are getting ourselves ready as far as repetitive operations are concerned. The critical resources, labor intensive operation, worker skills are manufactured then and there. We need to go approximately, we'll talk about it. So degree of automation is low and high. Throughput time is longer and shorter as far as intermediate and repetitive operations are concerned. Work in process is more or less more in intermediate process because it is customized. Less is in the repetitive process because it is more or less standardized thing. So I hope it is very clear to the audience of this particular video what is an intermediate and repetitive operations for process selection only. Now process selection types, there can be four types. Did I say about batch production? Yes, I mentioned in the previous slide. Batch production, batch A, batch 2, batch 3. And the example that I cited was your normal skin, your dry skin, your oily skin, and so on and so forth. Process for manufacturing your creams. So project process makes one at a time product exactly to the customer specification. Batch process is small quantities of product in a group of batch based on customers order or specification. Line process is all large quantities of standard product that we are looking into it. Continuous process, very high volumes of fully standard products. Process types exist as in continuum basis. Remember, this is what we are looking at it. Now, I have got a pictographical representation for you to understand for the audience out here, wherein the product volume and the number of unit that has been produced or has been plotted on an x-axis and it increases with the passage of time, whereas the standardizations gets absolutely on a higher things. If you look into it, it becomes easier for the process flow altogether. The higher the standardized products and the product volume becomes easier, it is becoming a seamless process. But if the standardized products is low, that means every other product is different than the previous one, then probably the product volume will not be as high but will be very complicated. It will be on a lower end, or even if it is very high, it is very pricey thing for you to do around it. So please understand the four steps. One is the project process, custom job shops or customer tailoring construction. Second is a batch process. Third is a line process that we go around it. Assembly lines are in cafeteria. Batch process is about education classes, bakery, printing shops. Continuous process is oil, refinery, water treatment plant, and so on. So if you look into it, project phase and batch processes are intermediate operation. Line phase processes and continuous processes are more or less a repeated process that comes around here. We'll take one at a time of each of these four processes, right? Process selection based on the five consideration types of process range from intermediate to repetitive, definitely yes. Flexibility of resources is of utmost importance. Degree of vertical integration is mandated. Mix between capital and human resource, degree of customer contacts as the case might be. Now we'll talk about process design tools. Often stages the production process can be performed in parallel as here shown in out here. If you look into it, this is a multi-stage process. Stage 1, stage 2, stage 3 is a multi-stage process as the case might be. But in point two, there is something called a buffer system that has been brought in, work in progress. So stage one, and then there is something which is work in progress, and then comes the stage two. So there is a buffer system that works around it. Parallel system when stage one and stage two are working simultaneously and coming with the finished good one, finished good two, probably they might be assembled together at one particular stage and finish it. Wherein parallel stages are continuously going and in tandem working with one another to come up with the finished goods. This is what we are looking for. So yes, this is the pictographical representation of process design altogether. Designing process design tools include process flow analysis, process flow charts. I have already elaborated on the flow chart thereby. Design consideration includes make to stock strategy, assemble to order strategy. Make to stock means you are making or producing at bulk and probably making an inventory, so and reducing the inventory as on when the demand arises. Similarly, assemble to order, it is only when you receive an order then you initiate the production process altogether. And make to order is somewhere down the corner, way to differentiate from the assemble part. Assemble to order wherein part ready, part of the products are already ready, you need to just mix it up and probably come up with the finished products. But in make to order, you wait for the order, and until and unless order has taken place, you initiate from the beginning. So we need to understand all together one by one the flowchart of different products as they've been set to it. Here it's make to stock strategy, ingredient, make dough, crust. I'm talking about a pizzeria out in this example. If you look into it, we are making the dough, we are preparing the crust, we have assembled the pizza, we are baking it, finished good, and delivery to the customer. Now this is make to stock strategy, but assemble to stock, we have already prepared the dough and prepared the cake. Now we are waiting for this orders to come around here. The moment the customer orders, we just assemble the pizza, bake, and delivery part of about it. See, a simple thing. But in make to order, we are still waiting for customers order to take place. The moment it starts, we start initiating the make to do thing. So you see the difference of making in a pizzeria that I've given it to you, where the customer places the orders. In make to order, only after receiving the customer orders we initiate. But when we are talking about make to stock, we build everything and wait for the ready-made customers to order, place an order, and we are ready to serve out here. In assemble to stock, we are part prepared, part ready for waiting for the customers to order. The moment the customer orders, we assemble the product thereby. So it's a very easy for you to understand as far as the pizzeria is concerned. The basic process performance metrics include throughput time that we are looking into it. Lower throughput time means more products can be moved through the system. One goal of a product or process improvement is to reduce the throughput time as the case might be. Definitely, yes, has been elaborated to you. Now, let us understand the PPM or the process performance metrics, which can be defined as the measurement of different process characteristics that tells us how a process is performing. Determine if a process is functioning properly, determine whether the performance is measured accurately. Determination, this is what we are looking into it. So what are we looking into it? Whether the functions of processing of the process doing it at an optimum level, and whether we can measure the performances. Is the customer being satisfied thereby n numbers of times? So let us continue with the metrics of process performance. The throughput time is the average time that a product takes time from order receiving the orders and probably placing the orders. What are the throughput times in between? So I've placed an order today and I received the order 3 weeks later. I place an order today and receive the orders 2 days later. I place an order today, within half an hour the delivery takes place. So you see the throughput time from 30 minutes to 14 days to uh, sorry, from 30 minutes to 2 days to 21 days time. So you see that that is what throughput time is all about it. So process velocity is throughput time and divided by value added time, as the case might be, a measure of wasted time in the system. Wherein productivity is all about output is to input, a measure of how well a company is running its resources. Utilization is time or resources has been used, time or divided by resources been available. The proportion of the time or resources been actually been used is what we are looking into it. Efficiency is actual output divided by standard output, measures performance relative to the standards thereby. So linking product design and process selection. Product design and process selection are directly linked. Type of product selected defines type of operation required. Now, type of operation available defines broader organization aspects such as equipment required, facility arrangement, organizational structures. These are things that needs to be taken into account every now and then. So let us understand the organization decisions regarding intermediate operation and repeated operation. In the decisions of product designing, it's an early stage of PLC. A product life cycle is intermediate operation, but repetitive operations is a large stage of product life cycle. So it's almost a standard thing. In terms of competitive priorities, we are looking at delivery, we are looking at flexibility, we are looking at quality as far as intermediate operations are concerned. But in repetitive, only two factors: cost and quality. Cost and quality. But here, intermediate operation, everything can go for a toss. We can look at delivery, flexibility, quality, customizations, and so on and so forth. Facility layout version, we will have the resources to be grouped by functions, a particular groups by functions. Let's say in cases of pizzeria, it might be different. In case of a tailor shop, it can be a different altogether. But in a repetitive operation, they are in a production process. They are always in a line, and resources are arranged in a line and line process takes place. Product strategies make to order, assemble to order for intermediate operations. You have seen the examples where the customer's orders have been placed in the middle of the process, where you make half of the product ready, or after receiving the orders, you initiate the manufacturing of the pizza. Similarly, but repetitive process is make to stock. You build it, you manufacture it, and keep it ready. The moment the order comes in, you just serve it out. So vertical integration is low in intermediate, where it is very high in a repetitive process, as the case might tell it to you. So we have these product design decisions. What are they? In the repetitive and intermediate operations, typically we are producing products in a different stages of product life cycle. Intermediate is the best for early product life cycle. Repetitive is better for later when the demand is more predictable, when we are assured of it that there would be a demand for ice cream, for pizza, for clothes, for jewelries, and we are looking into it. If we can predict that thing on a large scale, definitely yes, you should go for repetitive production. But otherwise, it is an intermediate process where you can be building it or making half of the product and not wasting all of your money onto the inventories per se. The competitive priorities, decision on how a company will compete in a marketplace. Intermediate operations are typically less competitive on cost than repetitive operation. Why? Because believe me or not, the repetitive operation are manufacturing on a large scale. They have their fixed cost, they have their variable cost taken care of. In fact, they are playing the business on the economies of scale. On the other hand, intermediate business are working on customization, so they will be pricing a little bit on a higher end. So that is what the linking product design and the process selection thereby. So we have what are the result, the depiction out here. If you look at it, intermediate operation, the resources are grouped by function. Let's say department A, B, C, D, E, F. So you can go with the pizza flow where is dough, cheese, other assorted toppings, probably bakery, baking, packing, and probably delivery part. It's all department which has been divided out altogether. Whereas in a repeated operations is the other way around, right? Where it is said it is an inbound material, workstation 1, 2, 3, and finished product. You put in your pizza, make your pizza from workstation 1, 2, 3, and your pizza is ready and store it. And by the time it has been produced, probably it is expected that orders have been placed, so it can be consumed on an immediate fashion. If not, probably it can be stored for a certain point of time or be maybe grilled at the moment the order has been taken place. Similarly, for types of operations directly related to product, directly related to the service strategy that we are looking into it, I have given you the three basic strategies: make to stock, assemble to order, and make to order. In make to stock, we already are anticipating a demand, or there is fairly a reliable trend that we can always expect to achieve. Assemble to order, built from a standard component, we are in between. We are not sure about it, but at the same time we should be ready for if there are heavy orders. We should be ready for an efficient services. Make to order, on the other hand, is produced to the customer specification. So the customer, if the delight factor is that it has been completely to the taste of the customer that we are looking into it. The pictographical representation, if you look into it, the delivery time for make to stock is absolutely minimum, where the delivery time for assemble to order is somewhere more than probably the make to stock. But the delivery time for the make to order is the maximum thing. Why? Because of the processes, the steps that we are taking it around it, the delivery time, if you look into it. And that is what I wanted to show you, depict you in this particular pictographical representation. As far as make to stock is quickly delivered, assembled to order is delivered with a standard time, but made to orders delivered with a very longish period of time, but then the quality of the product should thrill the customers altogether. Degrees of vertical integration in make or buy decisions. Vertical integration refers to the degree a firm chooses to do the process, whether by itself or it sells it, or it outsources it. So if it is doing by itself from raw materials to sale, so everything the firm is doing on their own, right from procurement, production, manufacturing, packaging, and selling. So it's a backward integration means moving closer to the primary of operation, forward integration moving closer to the customer operation. So from procurement to sales, procurement would be towards the raw material, sales would be towards the customization. So one is towards the backward integration, the other one would be a forward integration. Our firm's make or buy choices should be based on the following consideration. What? They are strategic impact, their availability capacity, where they are able to cater to such huge quantities, expertise, are they expert enough, quality consideration, speed, cost, fixed cost and variable cost, which needs to be taken into consideration. If fixed cost and variable cost are equal to the fixed cost and variable cost, should I go for making or should I sublet to somebody else, and the other vendor has to take the process into consideration or the headache out there. We need to go for the next big decision is technology decision, information technology. Simplify it. Can be on a ERP basis, enterprise resource planning, GPS, geographical positioning satellite, RFID, radio frequency identification. What technology that we are looking into it? What automations are we are going to go about it? Automated material handling, automatic guided vehicle AGV, or automated storage or retrieval system AS or RS. We are looking into it. So these are the inventories that can be taken care for. You have it, you do it, whether you are employing such technologies, whether you're taking artificial intelligence into consideration or machine learning into consideration or data chain analysis as a consideration, robotics and numerically controlled equipment as the case might be. We'll talk about e-manufacturing. Web-based environment creates numerous business opportunities, which includes product design, collaboration, product design, absolutely, which needs to be taken into consideration. What kind of product and who is going to be the consumer of that product? Process design, collaboration. Computer aided design is using computer graphics to design new products. Computer integrated manufacturing, integrations of product design, process planning, manufacturing, and using integrated computing services. Let us understand how designing services and how do they differ from manufacturing. Services would be differing from manufacturing as they have produced intangible products, involves a high degree of customization. Types of services is classified according to the degree of the customer contact that we go around it. Now this is where the intermediate production would be coming around it. It is all about the services that we are looking into it. So designing services, it will be the service characteristic which might be purely service oriented. It might be quasi manufacturing, mixed services, as the case might be. In pure services, we talk about restaurant, healthcare service, schools, hospital. Mixed services are all about offices, banks, insurance firm. Quasi manufacturing would be a warehouse, distribution centers, environmental testing labs, back offices. We have to have different design, different packages, different things for each of these services that we are looking into it. The physical goods, the sensual benefits, the psychological benefit comes in the sensory service packages. But what about differing design, substitute for technology for the people, getting customer involved, and high customization. So let us come back to product design, process selection across the organization. We are talking about strategic. We are talking about the finance part of the product design, process selection. Marketing is to be impacted by the product that the process is employing into it. We are talking about quick service, or are we talking about quality service, right? That we are looking into it as far as the example of Pizzeria goes around it. Finances is an integral part of the product design, thereby. And the last slide would tells me about the product design and the process selection mandate, which works closely with the mission and the vision of the organization. Remember, information service has to be developed to match the requirement of the production process. That is what the need of the day is all about it. Human resource, the employees provides an important input to the process selection decision for the staffing requirement. It also tells you how many numbers of employees are required to deliver or to service a particular process that we are looking into it. With this, I come to an end of this particular presentation. Thank you for watching this video. I am sure the process selection of the manufacturing industry, you must have got a very relevant and ambivalent idea about what exactly is expected and how will to go ahead with it. Thank you once again for watching this video till the end.